So we have a force time graph. We'll do an Oizerga analysis. There's our origin right in quadrant 1. The y-axis is force in newtons, time in seconds. So therefore, if the question is asking about force or time, it'll simply be read off the graph. The gradient, or the slope, is delta F over delta T, which is the rate of change in force. And the area is F delta T, which is the definition of impulse. And we know that delta P is M delta V, and that the impulse brings about the change in momentum, so they are mathematically equal to each other. So we have a cart A. Oh, so we have this graph. Let's just analyze that first. So we see the force increasing to a maximum and then decreasing back to 0. So it goes from 0 to a maximum and back down. The rate of change in force, the slope, is a constant. So that's a positive and then a negative, and they look like to have the same magnitude, the rates of change. And the area of this would represent the change in momentum. So you have a car A, which has a mass of 2 kilograms, 2.0 kilograms, constant speed 3 meters per second. A then collides with cart B with a mass of 1.5 kilograms with a V0 equal to 0. The force is shown in the graph. T0 is the instant of initial contact, so there's contact. B moves to the right with a speed of 3.2 meters per second. All frictional forces are negligible. Student must determine the final speed and direction of car A and considers using the following equations. Well, if we were to set about solving this equation, we would start out with conservation of momentum. And we have the momentum of A will be equal to the momentum of A plus the momentum of B prime. And the momentum of A is the mass, 2 times 3. And the momentum of A prime is 2 times the velocity of A prime, which is unknown. And the momentum of B, these should be P's, the momentum of B is 1.5 times 3.2. And 1.5 times 3.2 is going to be 4.8. So we have 6 equals 2 VA prime plus 4.8. So therefore, 2 VA prime is 1.2. And VA prime then is 0.6 meters per second. So what we can see is we definitely use this equation, the law of conservation of momentum. So they consider those equations. Which equation or equations the students can use? So it says only equation 1. Well, we know that's false because we just did it with equation 2. Only equation 2, that could possibly be true. Equation 1 and 2, and neither equation, that's false. So we're down to 50-50 just by realizing we can do it with equation number 2. So now it comes down to, is it only equation 2, or can we also use equation 1? Now we do know with this equation, which is true, delta P equals F delta T, we would need to know the average force and the time interval that it happened. Well, we do know the time interval that it happened. We know the maximum force, and we know the initial force. So the maximum force is 8,000, and the average force then would be 4,000. So the change in momentum would be the same with a constant force of 4,000 or the profile that we see below. So what we can see then is we can find the change in momentum of cart A. And if we know the change in momentum is P minus P0, and we want the instantaneous momentum, that is delta P plus P0, rearranging that equation. Delta P is due to the area. Oh, excuse me. We want the delta P. We use the average force value of 4,000. And the delta T, which is 0.00125. So that would give us the delta P. But that just gives us the delta P of card A. We want to know to determine the final speed. Well, if delta P is P minus P0, then P is delta P plus P0. Now, we do know delta P. We just calculated using F delta T, so check, we have that. And P0 we have because it's 3 times 2, check. So we can actually use both of these equations, 1 and 2, to solve it, not just equation 2.